So, yeah, that'd be helpful, wouldn't it? All right. So, we went through last time, and the payoff last time is lines and things with form y equals mx plus b. We talked through two different ways of thinking about equations for lines. One was y equals mx plus b, the so-called point slope intercept form. And the other one was point slope form. If you know a point on the line and you know the slope, then you know the line via this equation. Right, we did make it through that last time? Okay. So, here I think is the first thing I want to do. Let's describe those ideas in like just an algorithm to find an equation for a line. So if you're given 2 points on a line, these 2 points, sitting on a line, then you can find an equation for that line as follows. I guess either way, the first thing you need to compute is the slope. Is it easy to compute the slope given 2 points? Yeah. What is the slope given those 2 points? And there's like a half dozen reasonable things to say here. Yeah.
You do y2 minus y over 2 minus x over.
Yeah. There's the formula for it. The change in y is divided by the change in x's. If you'd rather remember words as opposed to that string of symbols, right, it's exactly what the slope should be. It's how much do you go up divided by how much do you go to the right. If it's negative, then it's negative. There's a divergence here. So we have like the two different philosophies on what an equation for a line should look like. There might be y equals mx plus b or the point slope form. Let's think about point slope first because it's, I guess, more immediate. Because you just like have everything. Do you know at least one point on this line? Yeah. Do you know the slope of this line now? Yeah. Well, assuming you've actually computed it. I'll do that to the, this way. Put in point slope form. Y minus, I know up here it's y0, but this point's called x1, y1. Pick one of those points, plug it in, equals slope x minus x1. Neato. There it is in point slope form. Do you think you could do that and then just solve for y and get it in the form y equals mx plus b? Yeah, so if you want point slope form, if you want slope intercept form, nice. So I guess the other strategy we had was we wanted to put it into the, if we just want the form y equals mx plus b. Well, I guess the strategy we had is you could like solve for b. Was the other way you could think about this? Plug in x1 and y1 and solve y1 equals slope x1 plus b for b. That seemed like something you could do pretty easily? Yeah, great. And as soon as you know that, you know everything. And one of those strategies isn't like better than the other. They're just two different ways of thinking. Both of those seem okay? So let's use this to do something which hopefully will seem reasonably applicable. So there are two standard outside of the scientific community means of measuring temperature, right? Or reporting the temperature the actual measurement is done with a thermometer. That's just what it is. You can measure temperature in degrees Fahrenheit or degrees Celsius. During this next exercise, let's determine the conversion between the two. And let's go, I guess, from degrees Fahrenheit to degrees Celsius. So I want to think of this as follows. So I want the input to be from Fahrenheit to Celsius. So I want to think of the input, so like the x value as being the temperature on Fahrenheit, and I want the output, so the y value to be the temperature on Celsius. And here is some, let's just see what facts people know. So 0 degrees Celsius is the temperature at which water freezes. And what temperature does water freeze in Fahrenheit? 42, right? Not a math fact, but that's a fact. I guess that's assuming like standard temperature and pressure, so you got to be near sea level for that to be right. And if you're like in the mountains, you might be off by a little bit. Anyway, it doesn't matter. So when Celsius is 0, Fahrenheit equals 32. And there's another fact here. When temperature is minus 40, you don't need to evolve which one, because minus 40 is the same in either temperature system, it's just cold. What other facts? Like, there are other facts you might know about Fahrenheit and Celsius. What's another thing you know about those temperature systems?
Water boils at 100 degrees Celsius.
So water, yeah, boils at 100 degrees Celsius. Yeah, so like, what is the basis of Celsius? Celsius is like asking a pot of water on a scale from 1 to 100, how hot are you? And Fahrenheit is kind of the same, but you're like asking a person on a scale from 0 to 100, how hot are you? Because like 100 is pretty hot and 0 is pretty cold. But anyway, that doesn't matter. At what temperature in Fahrenheit does water boil? 212. So that means when 100 is equal to C, 212 will be equal to F. So there's another point we could use. Oh, neat. Does that give us like some points that should be on the line that converts between these two? Let's pick two of them and use them to find an equation for this line, and then like use the quadrature. So what is a point that should be on this line if I'm thinking of the x-axis as Fahrenheit and the y-axis as Celsius? Yeah. 32, 0, and negative 40, negative 40. I'm definitely confident negative 40, negative 40. I'm not saying the other one's wrong. I'll need to think for a second. Negative 40, negative 40. So it should be F, which is 32, comma 0. You said 32, 0? Awesome. If you did the opposite, you would be like doing the conversion from Celsius to Fahrenheit instead, which is useful, but not what this problem is doing. All right, so 32, 0. So there's now a picture not necessarily drawn to scale. Is that enough information to find an equation for the line? And I'll give you all a choice. I do or you do. So should I keep talking or should I just let you run the algorithm? Should I keep talking? Cool. So I know 2 points on this line. I know those 2 points right now. So if you like, I just need to find the line between negative 40, negative 40, and 32, comma 0. So let's run that algorithm. Let's run the algorithm that's in those steps above. What's the slope of this line? And like people are being quiet, and ideally it's because they're just like doing the division carefully. Yeah.
5/9.
I hear a 5/9. Excellent. And I'll plot that as 5/9 because that's not something that'll have a terminating decimal expansion anyway. And so I'll never get perfect precision if I use a decimal. 5/9, and I guess it was like 40/72 that gives that. You know. Anyone want that discussed in more detail? Just the slope. All right. Do we have enough information to put this thing into point slope form? Which point seems easier to use? 0. 0 is the simpler thing. We could use -40, -40. That would be a perfectly valid thing to do. Let's take advantage of the fact that 0 behaves nicely. And I'm going to use x's and y's because I don't want to think about which of f and c is supposed to be like the input or output right now. I'll do that in a second. All right, so let's use this point. So it'll be y minus y0 is equal to 5/9 x minus x0. All right, and now let's just remember what y and x are supposed to be. What are y and x supposed to be? Y first, what's y in this problem? Say that wrong?
0.
Well, I'm asking the question wrong. So, I like plugging in the values, like I want what does y mean in this problem?
Oh, degrees in Celsius.
Degrees in Celsius, x is degrees in Fahrenheit. So, I'm emphasizing that point just because I did this an hour ago and I screwed it up and it took a quick minute before anyone noticed, which meant everything was wrong. All right, so y is temperature in Celsius is equal to 5/9 temperature in Fahrenheit minus 32. There's the conversion from Fahrenheit to Celsius. How do people feel? Does that seem pretty reasonable? Nice. And let's use that third point now to test. What is a third point that should be on this line?
212, 100.
212, 100. When Fahrenheit is 212, Celsius is 100. So let's do a quick thing to check. When F is 212, Celsius should be 100. And all those numbers seem big enough that I think generally I would resort to a machine aid to do the computation. And so if you want to, bust out your favorite calculator. I'll demo one just for the sake of demoing a tool that I think is handy to know that it exists. Oh, I have way too many tabs open. Oh, and by the magic of television, I've already done it. So, many people just already knew that you could like type expressions into Google and it'll compute things. All right, well, now you do know. And I'm pretty sure like any other of these internet search engines, they're called search engines, will do that also. Oh, neat. And it gave a result of 100. That's what I wanted to see. So I think that I trust this formula now. Cool. Oh, could you do something similar if you wanted to get something that converts from Celsius to Fahrenheit instead? Yeah. In fact, I think I would suggest, if you wanted that, doing something simpler now that we have this. Do you think you could take that formula and solve it for F? Yeah, that seems like the easiest thing if you wanted a conversion factor. Good. So, 10 minutes left. The two remaining topics, one of them is something you already know how to do. It's talking about intercepts. The next thing is talking about parallel and perpendicular lines, which, how many people already took a look at the homework that was posted in Canvas for Monday? All right, the last thing that we'll do today, we'll cover that. After today, we'll be back on schedule, and the due dates and stuff are all going to line up again. So I accounted for the fact that I've fallen behind. So let's do that. Let's find the x and y intercepts of the line given by this equation. And this is what we're going to do. It doesn't have anything to do in particular with lines. Let's just remember how to find x and y intercepts. How do you find the x-intercept of a graph? Yeah. Set y equal to 0. So that doesn't like grammatically fit there, but how do you find the x-intercept? You set y equal to 0, you solve for x. Let's do that here. Set y equal to 0. You'll get 0 equals 3 times x plus 4. That looks like something you can solve for x. Any people want me to do the algebra? Okay, cool. Then I'm going to wait a second, and you'll tell me what happens when you solve for x. What do you get? If you're a negative 4 over 3, that agree? All right. All right, so that's the x-coordinate of the x-intercept. So the x-intercept itself is the point which, albeit he didn't write it that way. How about the y-intercept? How do you find the y-intercept? Set x equal to 0. So let's do exactly that. In fact, is it even easier to find the y-intercept than it is to find x? Yeah, and that's generally true for functions. You don't have to do any algebra, you just have to plug in. So when you plug in y equals 0, what do you get for x equals 0? What do you get for the y-intercept? 0, 4. Nice. Folks feel pretty good? In fact, how many people did that without even doing any of the things that I didn't do? Yeah. Because the whole point of slope-intercept form is it tells you the y-intercept. So you could have just looked at that and said, well, I know that the y-intercept is 4. But it's not much more work to actually plug in 0. So, neato. So the last topic of the day, which, yeah, I can do that in this time, is the idea of parallel and perpendicular lines. So let's start with this. Here are two parallel lines. Two parallel lines, like two lines in the plane that never cross. What can you tell me about a comparison between the slopes of those? Yeah. Same slope. So two lines are parallel if they have the same slope. In terms of equations, y equals mx plus b and y equals nx plus b, if those are lines, they're parallel if they have the same slope. So m equals n, and let's do a quick example where we use that. Let's find the line through this point parallel to that line. So that means I'm looking for a new line, something in the form y equals mx plus b. What's the slope of this new line I'm looking for? 3 over 2. So it'll be of the form, well, let's just write this. Slope of this new line is going to be 3 over 2. Now that I know the slope, do I have enough information to just say what this new line is? Yeah, because I know a point on this line. I know that 1, 1 is on the line, I think. I'm not looking at the notes right now, but I think it's 1, 1, right? Neat. So, should I aim for slope-intercept form or point-slope form? Slope-intercept? Point-slope. Yeah, it's easier and the problem doesn't specify which one it wants. So let's put this in slope-intercept form. So it'll be y minus y0. So y minus 1 equals 3 halves x minus x0, which is also 1. And is that an equation? Yeah. If you wanted to put it in slope-intercept form, you could, but you don't need to. So that's how you find a new line parallel to an old line. Just use that they have the same slope. Hopefully you're given one other piece of information. Here are two lines, y equals 3 halves x plus 4, and y equals negative 2 thirds x plus 2. You can't see what I just did. And maybe we'll just check this. Do those lines actually look perpendicular? Yeah, so like geometrically, what does perpendicular mean? It just means that like they meet at a right angle. That should be 90 degrees. And that's what it is. Look at those formulas though. How are the slopes of those lines related? Yeah.
They're opposite reciprocals.
They're opposite reciprocal, where in this case, opposite means one is negative the other, and reciprocal means that like it's the multiplicative opposite also. Yeah.
If we were to have to describe like how a line was perpendicular, like on a homework assignment, like would it be enough to say like that the slopes are opposite reciprocal and then like explain why they are?
Yeah, in fact, at this stage, yeah, that would be good. Okay. I'm going to write that right here. Slopes are negative reciprocals of each other. I'm using the word negative instead of opposite, just because opposite feels ambiguous to me. So, but we can write that down formulaically. What does it mean to be the opposite reciprocal? It means that one of them is negative 1 over the other. And let's use this to do one thing. I have 2 minutes. I feel like that's enough time. This one. Let's find an equation for the line perpendicular to that line through this point. Do I have enough information to compute the slope of this new line? What's the slope of this new line? Negative 2 over 3. Because of this fact, the new slope should be negative 2 over 3. Do I know what point this thing goes to? Sure seems like point slope form, is it all? So because it goes to the point 1, 1, it looks like this is of the form y minus 1 equals negative 2 thirds x minus 1. Oh, neat. There's an equation for this line. So those who looked at the homework that was assigned for last time, does this now make you feel pretty confident in it? Yeah, no. Yeah. Depends on asphalt. If I ask you to put this in slope intercept form, then you need to do this. As long as you address the front side. And this is reasonably simple. There wouldn't be any walk to distribute as the one to the other side. This is nice and solid. Cool. So, on canvas, if I've done things correctly, there should be nothing new assigned today. Because at the end of today, I'm just caught up with what's scheduled to go. Good day. Let's stop this recording.